Does anyone know if anyone else specifically is coming, or maybe we should get started? All right. So working with Git and GitHub. Git is an industry standard tool. Can you hear me?
You're recording.
Yeah. Okay. Used throughout software development. I use it all summer at the company I worked at. Chevrolet did as well. And Git is essentially version control software. So as you develop software, you tweak things, you break things, you add features, you might add bugs, unfortunately. And with a tool like Git, it lets you keep track of all the changes you've made as you created your software. And basically creates a snapshot every time that you tell it to of exactly how your project is doing at this exact moment. And you can go back to that snapshot at any time to see what your code looked like at that moment. And it also has features for collaboration. With websites like GitHub, you can sort of back up your code by hosting it on their repositories. And it's not meant to be a backup, hence the quotation, but it's pretty great to have all your projects up in the cloud somewhere. One thing to be very clear though is Git and GitHub are two completely separate things. Git is the software that you use to do what I just described, and GitHub is just a website that integrates with Git easily and lets you share your projects and collaborate with others. But they're two separate things. People often get them mixed up. Just wanted to clarify that. So we're going to get started right away. How many of you are familiar with the command line, at least a little? Everyone is? Good. Okay. So we just, you can use your personal computer if you like, or you can SSH into Hydra, which I'm going to do just to make sure I'm matching all you guys if you're on Hydra. All right. And we're going to make a mock-up little project. I'm going to make a project called members, and you'll see why later. But just make a folder, call it whatever you want, and CD into that folder. And members, for me, is going to be a list of ACM members. But let's also, for now, make a Python file called hello.py that just prints hello world. So make any kind of file you want. Doesn't really matter as long as we add a file. And just going to make sure it works. Awesome. So we've made a directory now, and we're in our directory, and all the files in this directory are going to be part of our repo. A repo is what you call a Git project, essentially. It stands for repository. And it's a repository for all of the code and all the files that the project contains. So to initialize a repository, you type git init. All Git commands are going to start with git and then the action that you want to perform. So git init initializes it, and as it's telling us here, it made an empty repository, which means there are no files in the repository yet because we just made it. So to add a file to Git, you use git add. Pretty simple. And then the name of the file. And one other little trick is to add all of the files that have changed or that you've added to the project, you can use a star. So I know that I want every file in this project to get added, so I'm going to git add star. And then a commit, those snapshots I was talking about earlier are commits. So now that we have our file, we have a basic working version of our project, we're going to do what's called a commit. And then the -m stands for message, I think, and you always add a git message with your commit that describes what it is. And if you don't do -m, it'll pop up a VI editor for you where you can type a longer detailed message. But if you just want a short message and it's also a bit faster, you can just do -m. Okay, a bunch of text showed up. Basically, this is the first time I'm using Git on this machine, and probably most of you as well, if you got this message. So what it did is it set up a user for us, essentially. It's not a user account or anything. It's just a string in a text file somewhere. And it put my name in it, and it made a username for me, which is your logged in user and the host name of the computer you're on. And this user shows up in all the commits that you perform. So if you would like to right now, you can configure that with perhaps an email that you would rather have and your real name. So just copy the commands that it shows you there to do that. And for example, I'd rather just be Kyle Bashore. And put my email in there. And if you'd like to, you can amend the commit with this command. And that'll put your new username and email in the old commit that we just did. I'm not going to bother doing that. So GitHub, like I said, is a great place to store your code. And I'm going to walk you through making an account there and using that with your actual repositories. So let's go ahead and go to github.com. I'll sign out. And it's really just super simple: username, email, and password. So I'll give you guys a moment to create an account if you don't already have one. And if you do have one, just sign in. I need a authentication. And you may see something like this. You won't have all this stuff here, of course, if it's a new account. But yeah, I think most of you have had enough time. Does everyone have an account set up? So the first thing we're going to set up are called SSH keys. And these will let us interact with the GitHub website without logging in every time from the command line. They're super useful. Basically, every time you want to put your code on GitHub, you have to log in. An SSH key, basically, think of it as you create a lock, and you give GitHub that lock. And you have a key that works with the lock, and anytime you're going to give them code, it'll automatically give GitHub the key and say, look, I can unlock the lock, so you should let me put code here. And it's really just makes it a lot simpler to use Git from the command line. You can even set SSH keys up on any server. You can set them up with Hydra. I don't know if you noticed, but I just SSH Hydra to log in, and it automatically uses my key that I have set up. So to do this, these are the commands you're going to use. The first one checks if you already have an SSH key. So, for example, if you had one, let me show you what it would look like. You can see I have ID_RSA and ID_RSA.pub. If you do ls-ll-al on that directory and you have an ID pub there, you don't need to do the next few commands. But if, like me, on Hydra, you don't have any, then you're going to want to run these commands right here. So SSH keygen creates the key for you, and SSH add essentially adds it to there's a little service running in the background that is always managing your keys and sending them back and forth when you need to. Pasteboard copy is just going to copy it to your clipboard after you've created it, which we actually don't need to do. That's if you're manually adding it through the website. This command will, oh, my bad. You will need to do that. So I'm going to do this right now, and you can see exactly what I mean. Keygen, I'll give it my email to identify which key it is. Okay, so it's asking us where to save it, and we just want the default ID_RSA place. So if you just press enter without typing anything, it'll save it there. A passphrase, if it's a personal computer that you know no one's going to steal and log into, it's okay to have no passphrase, and it makes it easy. Like I said, you don't have to type in a password every time you use Git. On the other hand, if it's a key that you're storing on a server somewhere, you don't know who's going to have access to it, you might want to add a passphrase to it, which will be required to type in every time you use the key. And I don't want a passphrase because that's the whole point of the keys really, is to not have to have a password. So just press enter without doing anything. So this is just a random little image generated showing us the randomness of the key. I'm no cryptographic expert. Now we're going to add that to our agent with this command here, ssh add, and then we're just giving it the directory of our key. Okay, let me check that. Okay, this is what I'm missing. Everyone should type this in as well, and that'll start up the SSH agent. And it'll give us back the PID just to make sure that it started correctly. And then you can do SSH add. And there, our identity has been added to the SSH agent. Is everyone good with that? So now that we've done that, you can copy the key to your clipboard, or the public key. And that is not available on Hydra, so that's fine. We will just cat this directory, and you can see what it is and copy it manually. Alright, it looks like a bunch of gibberish. What you're going to want to do is copy the entire thing with no returns before or after it. Alright. And head on over to your GitHub account and click on Settings and SSH keys, and you're going to want to add an SSH key. I'm going to call mine Hydra, and then you paste it in. Don't do any new lines or anything, and add the key. And now we should be able to use this key with our GitHub account. Can everyone add their key? Good. All right. Now to test it out, there's this little command that we can use. And it might give us this message because the first time we're connecting to the server, so just say yes. And there you go. It should print out your username and tell you that you've successfully authenticated with GitHub. And did everyone successfully authenticate? That's this command right here. Good? All right. So now that our SSH keys are set up, we can easily add code to GitHub. But to do that, you first need to make a repo on GitHub and add that URL to your local repo. So to make a repo, use the plus button up here and new repository. And I'm going to do it as ACM so that you guys can do a cool thing later. And just give it a short, easy name, usually all lowercase with dashes for spaces, because this will turn into a URL. If you want to, you can give it a quick description. Members of ACM who attended the Git tutorial, for example, because that's what it will be. And public repos, anyone can see, anyone can download your code. GitHub, by default, only lets you have public repos. You can sign up as a student for up to 7 free private repositories, and there are also other websites that have private repos that I'll show you later. But for now, this is just going to be public. And we don't want to initialize it with README because we are going to be adding our existing repository. So we don't want to mess anything up by adding files from somewhere else right now. And now that we've created the repo on GitHub, it's giving us some nice instructions on how to add the URL to our existing repo. So what we're going to do, as you can see here, we already did all this with git init and our first commit and everything. So we just need these. Copy and paste this command into your Hydra repo. And what it's doing is you're adding a remote URL, hence the remote, and you're naming it origin, which is the default URL for the repo. You can actually have several different remotes that you push to and manage your code with. So paste that in. I need to cd back into my repo. And that worked. And then you're going to want to push your code up to GitHub with this command. And since we're using the origin, we can actually just type git push. And it's giving us warnings because it's our first time. Git2 changed some things. You don't need to worry about this. It's only if you're used to Git1's behavior. And my bad, we may need to specify master because it's our first time pushing. So copy it in just like GitHub said, and there we go. It tells you that it's uploading things, and it tells you exactly where it pushed the code. And if you go back to your GitHub page and reload it, there it is. There's hello.py, and it's available for everyone to see. So we already did this. From now on, you can just use git push, now that our repo is set up, to push your code. So now that I have a repo set up, I'm going to show you how to do something called a pull request. Let me do a quick thing right here. So I just deleted hello.py and added a new file called members.md, which is a markdown file. And I'm going to add all my changes to GitHub, make a commit, remove hello, add members. It tells me what changed. I inserted one file and removed another. And I'm pushing it up. All right. Now, I want all of you to go to this URL right here, github.com/acmutk/members. And you'll see this page here. And what we're going to do right now is fork the repository. So forking is when someone else has a repository and you want to make your own version of it. There's a button up here for doing that, and just click on that. I'm going to fork it to my own account, and as you can see now, we have, instead of ACMUTK/members, your own username /members, and this is your own version of the repository. And what I want everyone to do is, now that you have your own version, we're going to pull the repository to your computer. And the way you do that is with cloning. So cloning is how you pull down an existing repository to yours. So what you want to do is cd out of your existing repository and just anywhere where you're okay having this repo, and git clone, and you have to give it the URL of the repository. And on the page for it right here, SSH clone URL, copy that into the command line. And I already have a directory named members, so I'll just go remove it And there we go. Now you should also have a folder named members wherever you cloned it. And if you cd into members, I'd like you to edit members.md to add your own username to it. Just use vi, add your username, and save it. So after you've saved it, go ahead and do a commit. Let me change something so I have something to commit. And you only changed members, so you can do git add members or git add star. And then commit it, and you might say added my username to members. Yep. And after that, go ahead and use git push to push your code up to GitHub. So once everyone's pushed, you can reload the page, and on GitHub you can see 20 seconds ago there was a commit and it was added my username to members. And you can see exactly what was changed if you click on that. So what we want to do is, everyone's added their username, but it's on y'all's versions of the repo. I don't have those. So a pull request essentially says, hey, original owner of the repo, I made this cool change. Maybe it's open source software that you're adding to. Maybe it's a project you're working on with a friend. And I want to request that you pull those changes into your code. And that's what this little button here is for, this green circular thing. And if you click on that, it's going to ask you where you want to base the fork off of, which one you're merging into the old fork, and it'll show you what's changed. And if you click on create pull request, it gives you a little place to leave a comment to whoever the original repo owner is. So I might say I added my username usually this would be something way more cool, like I added a function to your code that does something useful, or I fixed a bug. And when you click create pull request, anyone now can see this pull request and can comment on it. And since I am a manager of the ACMGit account, I can elect to merge this pull request, which basically accepts it and takes the new code in. You guys won't see this, I don't think. So if I click on merge, I can confirm it. Now, when I go to members on ACMGit, that change has been integrated into the code. And as I can see, Tyler, you've done a pull request. So there's a conflict. What did you do, Tyler? No. So what happened here was I changed my K-Bashore line of code, but Tyler doesn't have that new change, so there's a problem with that. Now I'll show you guys how to fix a conflict in a minute, but for now that's how you create a pull request. It's up to the owner of the repo to ultimately fix a merge conflict, and that is that. I don't see any others. Can everyone get to this point? Do you need help?
Merge. Well, how do we do that?
Sorry?
Like after you push it back to your own?
Yeah.
And then after that we'll
Okay.
just send it back basically to the ACM.
So members. This green button here, click on that. And I don't have anything there, but if you had a change, did you push up your change? Now we've all done a pull request, and let's see. And as you can see, I can merge it. I can merge. I don't know if there's a bulk way to do them. All right, now that his pull request has been merged though, when we open members, you can see that mine's not the only one there. So that's how you collaborate with other people on GitHub. If you see a project you want to contribute to, or if you're working with a friend. So that's most of the basic stuff of how to use Git, but there are a few other useful features I'd like to go over. Branches are really useful. Think of your Git repo as a tree, and you're working on the project, but maybe you want to work on a separate feature that might break some things in the main project. What you can do is create a branch and do whatever you want in that branch, experiment with it, change a lot of stuff, and even though other people are working on the main branch, you can break things in your branch without affecting them. It just sort of, it does exactly what it sounds like. It branches off and essentially gives you a new place to work on your code. So if you still have your members repo up, which hopefully you do, we're going to create a branch that maybe we could add a goodbye.py file. And for some reason that might break things, so we want to do it in a separate branch. So we're going to type git branch and then the name of the branch, and name it something that you can recognize what it's doing. So this has created a branch, but we're still on our main branch, which by default is called master. So to switch to this branch, you just use git checkout and the name of the branch. So git checkout goodbye. We've switched to branch goodbye. So in goodbye, we're going to add a file maybe called goodbye.py. And we've done that. And before we switch back to our master branch to work on something else maybe, you always want to make sure that you've committed to any changes that you want. So we're going to add goodbye.py and do a commit message. And now we're all set. In the branch goodbye, we've added goodbye.py. And if we do an ls, we see it there. Now, here's where it gets kind of cool. If we go back to our main branch, which is called master, with git checkout master, goodbye is not there. It's nowhere to be seen. Because in this branch, goodbye doesn't exist yet. And we can also push our goodbye branch up to GitHub if we switch back to goodbye and do a git push. Now when I go to my members repo, I have to specify that, sorry. Git push goodbye. Again, I'm not too familiar with doing this via command line. Do you know why? Okay. Okay, that's the right way to set it up the first time you push a branch. Git push origin. Origin is specifying where we're pushing it to, and then the name of the branch you want to push. So git push origin goodbye has pushed our branch goodbye, which you can see on GitHub with this little drop down. Goodbye is also on here now. And if you click on these branches at the top, that was right here, you can see all of the branches that are in the repository. So let's say I'm done working on the goodbye program and I want to merge it back into master. Switch back to your main branch, the one that you want to merge into, with checkout. And it's fairly simple. There's a command called merge where we can get merge goodbye, the name of the branch we're merging. And now we've merged all of the changes we had in goodbye into our master. So we're still in master, and if we ls, we'll see goodbye is here now. So we can add our changes, commit our changes, merge branch goodbye into master, and apparently Git automatically does a commit when you do a merge like that. That automatically works. So we didn't actually need to do that. My bad. But if we git push, our master branch now has goodbye. So that's really useful. Yes, question?
Is there any way in command line to check which branch you're in if you forgot?
Yeah, I think git status is useful. And it tells you which branch you're on. It tells you if you have things that aren't committed. So if I vi goodbye.py, and maybe I'll change it. Okay, I don't know what I did.
Control C. You hit the double colons.
Alright, I've made a change, and I do git status. I'm on branch master, but I have some changes that are not staged yet, which means I haven't committed them. I haven't even added them to the repo. And it's telling me which file that is, which is goodbye.py. So git status will sort of show you what's going on right now. So I know now that I need to add my changes and do a commit. So git status. Now it's saying they have been staged, which is what happens when you do add, but they haven't been committed. So to finish that up, I would just commit. And after that, our status should say everything's working well. Any other questions about that? So conflicts can sometimes arise. I am not an expert at fixing those via command line, so I'm not going to try to teach you. But you can diff two files with git diff. And this is a great little guide. I'll make sure to send this PowerPoint out to you guys. I thought he mentioned diff. Yeah, so we can look at so since I just changed goodbye in master, it's different than what was happening in the goodbye branch. So git diff lets us compare what's different. We're going to compare master to goodbye. And what happens here is it tells us which files are different, goodbye.py, and it also tells us what changed. One line was added and one line was deleted. That's the +1 and the -1. And it thinks we deleted a line because we modified one, and it thinks we added a line because we modified it. So basically we removed one line and added a different one. And it shows us what's different. So now let's say I didn't want to change hello, which of course I don't, doesn't make sense. I can see what's wrong and fix it. If you make a bunch of changes, it's pretty useful to diff your code. Where did my slides go? There they are. Let's say that you've worked on your project on Hydra, then you clone it on your laptop, make some changes, and push it up. After that, if you want to work on it anywhere else again, you have to git pull, which simply pulls all the latest changes from the repo. So it won't do anything for me since I'm up to date. But if I had any changes that were on GitHub but not on my local machine, git pull will pull all those changes down. You can see a history of your commits with git log. The first thing we did was remove hello.py, which I didn't actually do, and add members, add my username, add goodbye.py, and change goodbye.py to print hello instead. And that's useful to see a history of what you've done. And that's most of the basics. If you'd like, if you guys have time, I can go over source tree really quickly. It's a GUI for using Git, which I use at work and it's really great.